Good evening and welcome you all. So today is the third day of our seminar series, which is conducted by the Zonal Education Office Gampaha. So I'm not going to introduce myself because we have met earlier. So today I'm going to discuss about logic gate. So logic gate is a bit confusing lesson for you all. So because of that, I will discuss some theory part first, and then I thought of going questions, past paper questions, model questions, and finally you will be getting, as usual, you will be getting online quiz that you have to answer within around 30 minutes. That's how it flows. Okay, we'll start. So when you are talking about the logic gates, so I'm not going to discuss them deeply, but I will be revising them all, right? So when you are when you are discussing about the logic gates, there are several logic gates in your syllabus. Those are NOT gate is there and O. So these are called basic gate. Basic gate. Then you have combinational gates, NAND. No, these are the combinational gates. So these are the things that you should know in your syllabus, right? So I'm going to discuss them. So before I discuss them, when you take a logic gate, right? Logic gate, suppose this is my logic gate. This side you have input. This side you have input. Then this side you have output, right? This side you have input, this side you have output. So whatever the gate, this is the structure of that. So you can have either 1, 2, 3, 4 inputs. More than 4 even it's possible, but in your syllabus you will be learning up to 3 inputs, right? But remember, all the time you have one output. All the time you have one output, right? So this is the basic structure of the logic gate, right? So whatever the gates we are going to discuss will be applied for this structure, right? So if you have one input, so I take it as A. So if you have one input, now we have discussed computer can understand zeros and one. So whatever the input for the logic gate should be either 1 or 0. So you cannot have values other than that. So if you have one input, that is 1 bit, you can have either 0 or 1, right? If you have two inputs, say two inputs, I take AB. Doesn't matter, you can take any letter. Input 1, input 2, doesn't matter, anything can be taken, but I am easy for me to use AB. If it is AB, my inputs are AB, I can write, I told you that one input can have either 1 or 0. So here, if it is 0, this become say 0, one input. So another input I can take 0, here 1. Different. So these are the different inputs. So I can take 1 plus 0, 1, 1. So this is, if you get two inputs, you can have 4 patterns like this. So how to find it out? If you know how many inputs are there, you can find out how many patterns are there very easily by using 2 to the power. Power is number of inputs. If it is one input, 2 to the power 1 equal 2. 2 patterns are there. If you have 2 input, 2 to the power 2, 4 inputs are coming. If you get 3 inputs, 2 to the power 3, 8 inputs are coming. So all these input patterns should be different, unique, right? So this is the basic thing. Before you before we talk about the logic gates, right? So this is how inputs are generated. How many now? That is the first question. Like if you get input 2 inputs, how many patterns are there? If you get 3 inputs, how many patterns are there? That is the main thing that you should know, right? So you can find it out easily by taking this. Okay, now we'll go to the logic gates. I am taking now these logic gates. What I am discussing, you have to memorize, right? You have to memorize. There are easy methods to memorize. Without memorizing this truth table and all that, you cannot uh, do a kind of a question even, right? So this is compulsory. You have to memorize this one, right? So if you take AND gate, I am taking AND gate, and this is the symbol you have to use, right? This is the symbol. Now I discuss this side you have input, this side you have output. If I take AB as input, my output, I have to write my output A dot B. So if you see this AND gate, right? Or if you see this expression A dot B, if there's a dot, you should know that is a AND gate. So without having this symbol, even you can understand it is an AND gate. How? Because you have dot between this A and B. So A and B inputs have combined or fixed into a AND gate, right? So if you take truth table means if you give inputs like this. Now I have four patterns because I have 2 inputs. My output will be, I'm going to write my output. So if you give 0 0, what is your output? If you give 0 1, what is your output? That you have to understand. To explain that, I am using normal circuit. This is a bulb. So I am taking this batteries. I am taking these switches A and B like what we have. So 0 means I take off, 1 means on in this switches, right? So if these 2 switches, 0 0 means what? In this, according to this circuit, 2 switches are off. So what will happen to this bulb? Will it light it? No. So you have to light this off. You can represent it with 0. If 0 A is 0, B is 1, that means one switch is on, one switch is off. Still bulb won't work. So again I put 0. A is on, B is 0. Again one switch is on, but current electricity is not passing through this one because it's not going to jump from like this, right? So it won't work. Here also 0. 1 1 means both the switches on, that means both on, then your circuit is complete, your bulb will work. So here I have to work. So this is AND gate. So you can, there's another method we call AND gate is a multiplication. AND gate is a multiplication. So multiplication means if you multiply 0 0 you get 0, 0 1 you get 0, 1 0 you get 0, 1 1 only you are getting 1. So multiplication, if you remember AND gate is multiplication, even doesn't matter, you can get the output. Or you can just remind this circuit, or you can just remind 1 1 only you are getting 1, others are 0. Right? This is AND gate. I'll go to next gate. This is I'm going to OR gate. O, right? You have to draw it like this, like a small fish. If you input AB, your output will be A plus B. If you see plus mark, okay, you can decide it's a O gate, right? So I am taking the A plus B here. Now I am changing the circuit. I am connecting switches like this, and both switches off, current won't pass, so your bulb won't work, output is 0. If one switch is on, B is on, what will happen? The power is going from the switch and the circuit is complete. When the circuit is complete, that means bulb is working. You can put 1. So other way around, that is, this one is okay, this is off, that is also working. Both are on, definitely they are working, right? This is the O gate, right? This is the O gate. So here we can memorize this like addition. If you add 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, you get, there is a problem because you can't represent 2. So there also you have to put 1. So either way around, you have to memorize how this truth table, right? Then I'll go to another gate. I'll go to not gate. So there's a difference. What is the difference? If you have only one input, that is the difference. You have only one input. You can't have 2, 3 inputs. You can't have only one input. You can have. That is the. So if you give input, you are getting the complement of that. Complement, other side of that. That means if you have input A, I'll use A dash or A bar. Other side means A dash or A bar. Now here, if you give 0, you get 1. If you give 1, you get 0. Right? So I can draw the circuit for that one even. This is my switch. This is a bulb, and I am using a resistor. I am using resistance that obstacle the flowing the current. Right? This is called resistance. This is the symbol, right? So when there's switch is off, the switch is off. What will happen? This is bulb. This is switch A off. So your output is bulb is working. So current is flowing like this. That's why I have put here 1. If the switch is on, this switch is on. So bulb is not working because current flows the path where you get the less obstacle. Now that's why I told here you have a resistance. Because of the resistance, you don't get the bulb light. So current is flowing path where you get the less obstacle. So bulb is not working. Right? In practical, if you connect like this, if practical, this bulb will slightly lighten, right? But in the theory, we are talking like this. Right? Okay, then I'm going to another gate. NAND gate. NAND gate. So NAND gate I can draw like this. Actually, it has NOT gate. With the AND gate, it is connected NOT gate. That's how NAND gate has generated. NAND gate has generated. So like the earlier, if you get AB, your output will be A dot B dash. Whole thing dash. Not separately, whole thing you have to put a dash. So if you get AB 0, 0, 0, 1, 1, 0, 1, 1, your output will be other side of the AND gate. Other side of the AND gate. I will draw circuit, then you can understand better. circuit looks like this, right? I have connected bulb like this. When switches are off, bulb will be working because the circuit is completing like this, right? So AND gate, other side of the AND gate. If you can't remember this one, remember other side of the AND gate. But these things you have to remember because sometimes you will be getting this type of question for the MCQ, giving this type of a circuit and asking what is the gate, right? So here I put 0, 0, you get 1. So one gate switch is on, still the power is not going, current is not going, flowing. So here you get 1. Bulb is working. When the both switches on, that's the same theory which I told you. Here I have put a resistor to make it patrical. So because of that, it won't work, bulb won't work, but power is going, circuit is complete. So if the switches are 1, 1, your bulb won't work, that is 0. This is called NAND gate. This is called NAND gate, right? So these things you have to memorize. Then I'll go to final one, NO gate. It's like this. A plus B dash, that is also combination of O and NOT gate. That's the combination of O and NOT gate, right? So I'll write A plus B dash. So here the circuit will be looks like this. Okay, right? So if the both the switches on, both the switches on, bulb will be working, that's 0, 0, your output will be 1. But if you switch on one switch, A or B, say, so power, that current goes less, path where you get the less obstacle. So because I have put a resistor here, so your bulb won't work. So here 0, here 0, here 0. So other side of the O gate. Now if you can remember O and, definitely you can remember NAND and NO because other side of that. And not you have to remember separately, right? Okay, so I am giving small polling. Put your answers there. And I want to tell you another thing before I now dash, instead of this dash you can have, I write here A plus B dash, or A dash you can represent like with the apostrophe, right? That is also possible. So some books, some papers you will be getting something like this even. Don't worry. Same thing. This is called A plus B dash. Same thing here. A dash means same thing A dash, right? So same thing can be represented in different ways, different books. So remember that one also. Okay. I am giving you the poll. Put your answers. Okay, I have launched. I think time is enough. Okay, I will end the polling. And I am sharing the result. Now you can see how you have answer, right? First question, a gate is blank. Gate gives the output as 1 only if all the input signals are 1. So both the inputs are 1, you will be getting 1, that is AND gate. So 86% students have put the correct answers. Now I am wondering, right? I'm wondering because if you were with me here, if you were with me from the beginning, if you were attending or if you were concentrating on my work, definitely you can answer this one. Very easy question. I drew that in the on the board and show you, right? So second question, the Boolean expression of OR gate. So A plus B, third answer, 94% have put the correct answer. Only 3 students have put the wrong answer. So there also I don't know, I can't imagine, right? How you have made that kind of a small mistake, right? So those who made that mistake, you have to work hard. Otherwise, you will be in trouble. Next one, which of the following gate will give 0 when both of its inputs are 1? So both of inputs 1, you get uh, 1 for the AND gate, but NAND gate only you are giving 1, 1 becomes 0. Others are 1. Other outputs are 1. So because of that, NAND gate 74% has put the correct answer. Okay. So we'll go to another part. Now I explain what are the logic gates. So you will be getting different types of question from this part. Right? One kind of question is you will be getting the circuit and asking what is the output. We'll see how to do that. I will draw one circuit. Right? So I am asking what is the output here. So this is one type of question you are getting. You will be getting circuit like this, combination of circuit, and asking the output. We'll go step by step, right? Now here, first you have to identify the circuit, identify the gate. That is the basic thing. That's why I told you have to memorize. Right? If you can't remember the symbol, you can't do this question. First thing you have to identify the gate. This is AND gate. AND gate. So if you input AB, now you know if you get input, what is your output? How to write that? A dot B. A dot B. Here C is input. This is a NOT gate. NOT gate. If you get C, what is the output? C dash. C dash. Right? Then for this is what? This is no gate. This is no gate, right? Okay. Students are sending the answers. Okay, very good. So here I am taking A dot B here. So this is the input for this part. Now look at here very carefully. This is the input for this gate. This is output from this gate, but this become an input for this last gate, right? This last gate, that is the input. So from this part you are getting A dot B. From this side you have C dash, right? So how they have connected with a NOR gate, How to write NOR gate? You have to put plus, and I told whole thing dash. So this is your answer. So when you get something like this, you better put brackets. Otherwise, you are giving a different meaning for that. So you better to put brackets like this, right? Okay. So I think if you want, you can take it down. So step by step, you have to do. So I'm going to give you another one. You can send me the answer through the chat. We'll see. Okay, look at this one. AB. Okay. Try to find the answers. Try to find the answer. This one I am expecting your answer. There is a no gate here. Here and gate. Make sure you put the correct answers. Okay, most of you have put the correct answers, right? Okay, I will. We'll see. We'll see. Right? Here you get no gate. Here you get no gate. So you can write A plus B dash. So in your case, you have to write it. That's why I told you have the different method. You have to type it. So you can write A plus B. Put a bracket and put a dash like this. That is also correct, right? So when I'm writing like this, but when you're typing, it's better you to type because you can't type like this. So you have to put like this. Doesn't matter, right? Same meaning. Here I'm getting C dash. When it is go to this side, C dash dot D dash. C dash dot D dash, whole thing dash. So when it comes to the final output, your answer will be A plus B dash dot C dash dot D dash. This is your output. If you put a bracket, doesn't matter, you can put the bracket C. Right? So this is your final answer. I think most of you have put correct answers, but most of you haven't put the answers. So I feel you are having some problems, right? Okay, you can after finishing this lesson, you can watch this video again and again. try to understand this bit confusing lesson. That's why I told when I'm beginning, at the beginning even. But and you have only 5 gates, but when it comes to the A level, you have 7 gates for that XO, XNO, and all that. But you don't have them, right? So this is a bit easy because you have less things to memorize, right? Okay, this is one method of getting question. Okay, I'll go to another type of question. Another type. I'm not going to take several examples because I have limited time, right? So this is one method of getting question. That means you will be getting a circuit and asking the output, final output, right? This is one. There's another way of getting question. Expression will be given. Expression will be given and asking you to draw the circuit. Asking you to draw the circuit, right? So here you have to identify A plus B dash. A plus B dash. Now, if it is A plus B, it is a O gate. With the dash, it's a NO gate. So I'm drawing that. Then A plus B again. So A plus B means O gate. So I am drawing that one also. Those two expressions have connected with the dot. Now you know dot means it represents the AND gate. So I am drawing the AND. So this is your final output. This is your final output, right? So I think we can understand that. So I am giving small questions. You can draw it in your paper or somewhere, right? Then when we are discussing, check whether it's correct, right? There's a method of taking your answers through the pattern, but it takes time to check and all that. So because of that, I am not going to take it. Okay. I am giving some expressions. Try to draw. Try to draw. A dash dot B dash dash plus C. Right? Plus C. First one. I'll give another one. X dot Y dash plus X dot Z whole thing dash. Whole thing dash. Okay. Try to draw them. I'll give you a few minutes. Okay. Yes. One student is asking question. Yeah. I'll explain that. I'll explain that. That means he's asking now if you have AB like this. If you have AB like this, so you have a gate like something like this. So he's asking whether we can take the AB from this one. Yes, possible. So when you are taking, either you have to bypass this one like this. So whatever it is, or you can put a dot like this, and you can take the same. Doesn't matter. You can take, huh? Doesn't matter. Okay. These are the two gates which I have given. We'll see how to draw that. First one, A dash dot B. Now A and B is not connecting. Connecting what? A dash and B dash with what? Dot and dash. That means NAND gate. So I am drawing A dash, B dash with an NAND gate. And C also coming. C I am taking. And C is connecting with the O gate. So I am drawing the O gate at the end. Check your answers. Check your answers. Okay, I'm going to next one. X dot y dash, again dash, plus x dot z, whole thing dash. So here x dot y dash. So x I am taking, y dash, not y. So I have to use a NOT gate. Then how to connect dot and dash? That means NAND gate. NAND gate. Then here I have x dot z. X dot z. So I am taking x and z with an AND gate. Then connecting with plus. This plus belongs to this dash also. So it is a no gate. No gate at the end. Right? I think you can understand that one. So we don't have much time to discuss more examples, right? So you can, when we are doing the past paper also, you can understand this part. Okay, this is another method. So we discussed two methods of getting question. Other one is drawing truth table. Drawing truth table. Sometimes you are getting the circuit and finding the truth table, or sometimes you will be getting a question, that means expression at once, and asking you to draw the truth table. So I am taking one, a plus b dash dot a plus b. This is my expression, right? So I'll take x, right? This is my expression. So they are asking us to draw the truth table. First thing is you have to identify variables. You have to identify the variables. So how many variables are there? A and B. A and B are the variables. So that means two variables. We discussed at the beginning. You have four patterns. Four patterns. So I am writing it once. A B 0 0 0 1 1 0 1. Then I am taking this part separately. A plus B dash. Then I am taking A plus B. Then finally, this x. For x means this whole thing, right? Whole thing. Okay. Then A plus B means what? no gate. Now that's why I told at the beginning you have to memorize these uh, truth tables. If you get a plus b dash, that means no gate. A and b is connecting with a no gate. A and b is connecting with a no gate. So 0 0 you get 1, 0 1 you get 0 0. This is your output, a plus b dash. Then here you have a plus b, right? So when you have a plus b means O gate. 0 0 you get 0, here you get 1 1 1. Now this is the confusing place. X means what? A plus b dash dot a plus b. So now inputs are not a and b. Inputs are not a and b. Inputs are what? These two expressions are connected with a dot. Now you have to check these two expressions for to take the final output. So here you have 1 and 0. Now I am taking these two. I am not worrying about these things. So if you get 1 0, your output, because it's an AND gate, get 0. 0 1 0. 0 1 0 0 1 0. So your final output all are zeros. All are zeros. Right? I think you can understand that. Okay, take a look on that. Okay, I'll give you another question. Shaman is asking, sir, could there be x twice? I mean, same input. Yeah, same input can be divided into 2. I'll show you. Now it's like this. Shaman is asking something. So if you get x, but x one input, but you want to connect this to AND gate. So can't connect AND gate because AND gate you have to have at least 2 input. So you can make it like this. So your output will be x dot x. That is possible, Buddha. That is possible, right? You will be getting this kind of question in your past papers, right? So don't worry, we will be discussing that. Okay, I'll give you another expression. Try to draw the truth table for that, right? A dash dot b plus a plus b whole thing dash. Okay, I'll give you a few minutes. Try to find out the answer. After finish, send me a message, then I can understand. If you can send me the output also. Only four outputs are there. You can put the answers in the chat box. Yes, x dot x means x, same thing. You don't worry about those stuff. That is laws. You don't have laws. In A levels you have them. Put your outputs. Okay, right? So you are giving the answers. Okay, we'll see. So AB are the inputs. 0, 0, 0, 1, 1, 0, 1. So I am writing A dash. A dash first. A dash means other side of A. Other side of A. That means 0 become 1, 0 become 1. Here 0, here 0. Then I am writing A dash dot B. A dash dot B. Now, remember, now you are taking A dash dot B. That means A dash and the B. These two only you are not worrying about A. You are not worrying about A, right? So 0, 1, you get 0. 1, 1, you get 1. 0, 0. Then I am writing A plus B. A plus B, right? So A plus B, O gate. So there you have to concern about A and B. A and B. So 0, 0, you get 1. Sorry, 0. Here you get 1, 1, 1. Then your final output, these two. Now you don't worry about this part. You are worrying about these two connecting with plus and dash. Plus and dash means no gate. Plus and dash means no gate. So 0, 0, you get 1. These all are zeros. I think most of you have, we'll see. Yes, yeah. Right. Most of you have put the correct answers. Very good. Right. Okay, Buddha, right? So I think you can understand this. So I'm not going to go in detail this part. So if you have three inputs, only thing is, only difference is you have 8 patterns. You have 8 patterns. I'll take one. X equal A plus B dot C. I'll take a small one. A plus B dot C. Right? So A, B, C, you take the 3 inputs. Zeros, 4 zeros, 4 ones. So 2 zeros, 2 ones. These are the patterns. You have to write the patterns quickly. Right? Then A plus B. You have to check the A plus B. These two. 0, 0, 1, 1. Right? Then final output. This part and the C with the AND gate. With the AND gate. So here you get 0, 0, 0, 1, 0, 1, 0, 1. This is your output, right? This is your output. So there's nothing because if you can remember this, how you have to these two tables, even you get 3 input, 4 input, even doesn't matter, same pattern, nothing will be changed, right? Okay, so I will go to another type of question, right? That is, you are getting kind of a scenario. You are getting kind of scenario and asking the question, right? So I'm going to share the screen. Okay, I think you can see them. Wait, these are some past permission. Yeah. Okay, this is the question. Wait. Right. This is the question. Now here you have a kind of scenario is given. So try to find out the at least logic circuit. If you can find out the circuit or the expression, you can definitely draw the circuit and draw the truth table. Now we have discussed that. So first thing is you have to find out the expression. So how you have to find out the expression? So just read it. An alarm sound when certain condition occur in a nuclear reactor. The output X of a logic circuit that drives the alarm must have a value of 1. So when logic say, that means that the alarm is working when there's a value is 1, right? Either some of you are telling screen is small, you can double click and you can pin the screen, then it will be okay. In your phone or laptop, you can make it larger, right? Or you can zoom it, even doesn't matter, right? Okay. Record the output X of logic circuit that drives the alarm must have a value of 1. That means alarm is working when the value is 1. Either carbon dioxide pressure too low and the temperature less than or equal 300 centigrade, or water pressure greater than 10 bar and temperature greater than 300 centigrade, right? So first thing is we have to build up expression. Build up an expression. So I'm going to type it here. Now they are telling output is X. Alarm will be 1. That means X will be 1 if what? Either carbon dioxide pressure too low. Carbon dioxide pressure, now you can see the table. Carbon dioxide pressure too low means carbon dioxide pressure P equals 0. So I am writing P equals 0. Yeah? P equals 0. And temperature less than or equal 300. Temperature, now look at the temperature. Temperature is denoted with T. Less than or equal 300 means T equal 1. According to binary value, it is called 1. So T should be 1. Right? This is one method. It is that alarm is working. O, they have given in the question, O, water pressure greater than 10. Water pressure greater than 10. Okay, water pressure is W. Greater than 10 means 0. So W equal 0. W equal 0. And they have given and temperature greater than 300. Temperature greater than 300. Okay. Temperature greater than 300 means that is also T equals 0. Okay. Now I have built up my expression. Now what I have to do is I have to put into logic expression, make it to Boolean expression. So how to do that? So P equals 0 means what? It is dash. Now we discussed at the beginning, 0 denote it as dash. So I can write P dash. P dash. N means dot. Now we know. T equal 1. So T, you can take it normal. It doesn't matter. O means you can put the plus mark. W equals 0. Again W dash. N means dot. T equals 0. Again T dash. So this is your output expression. This is your expression. Now it's better, I told you, if you can put brackets, it's better. If you can put brackets, better. So if you now, I'm not going to draw the circuit. Now you can make it happen, right? And I'm not going to draw the truth table even. You have three inputs. If you can take them separately, you can easily get the output or truth table, right? Okay, I'm giving you a question. Some of you have put the answers also for this one also. Very good. Vidushi. Okay, good. Okay, we'll say I'm giving another question. I'll give you small time. You can do it. First, you try to figure out the expression. Then you can draw the circuit or the root table without any problem. Okay. Try to figure out the expression and send me through the chat. Okay, I'm giving few minutes. I am waiting for your answers. Okay, okay, we'll see. We'll build up the expression and along y equal 1, that is y equal 1. if alarm y returns value 1, either temperature greater than or equal, temperature that is T greater than or equal 120. So T greater than or equal 120 means T equal 1. And star bar is off. Star bar off means S equals 0. S equals 0. O. Acidity greater than 5. Acidity greater than 5 means A equal 1. And temperature less than 120. Temperature less than 100. T equals 0. So after finding this very easily, you can make it happen. T dot S dash plus A dot T dash. I think most of you have put the correct answers here. Yes, good. Okay. Shania is asking me to put the recording. I can put the recording in my channel, ICT and Research channel. So I'm uploading all this seminar series. Okay, most of you have put the correct answers. Yes, good. Yeah, right. Okay. Yeah, it's better to use brackets. Now this is not complicated, but there are some places you get confused. So it's better to use bracket. Then it is more clear. Otherwise, you can make it T dot S dash plus A separately. So that then it's wrong. So it's better to use bracket to give like a kind of a sense of that, right? If you don't even use the bracket, doesn't matter. In some cases, um, you will be having problems. Okay, channel name is ICT Anil sir. I will write on the board later, right? At the end of I'll tell you. Okay, so these are the questions you are getting. That is type of question. Okay, I'm going to do some past paper question. I'm going to do some past paper question. Uh, I have extracted question from 2017, 18, and 19, right? Okay, we'll go to them. There are some MCQ questions as well as essay type questions are there. Okay, 6 and 7. Try to find out the answer 6 and 7. Okay, I'm getting the answers. First one, so here you get A plus B. When it comes to here, A plus B dot C. When it comes here, A plus B dot C dot D. So here final output will be A plus B dot C dot D plus here you are getting A E dash. So second one is the answer. Second one is the answer. Okay, seventh one also try. Here asking for given input, which of the following logic circuit provide the same output? So there you have to be confused, and you have to you can use different methods, but I think it's better to use giving inputs and check. As example, I am giving 0 and 0. For both I am giving 0 for all this stuff, right? So you, when you get 0 here also, you get your output will be 0. Here also if you give 0, everything will be 0. Here also 0. From by giving 0, I can't understand that, right? By giving 0, I can't find it out. So I am going to give 0 and 1. 0 and 1. So if I give 0 and 1 here, your output will be 0. Right? Your output will be 0. If you if you give 0, 0, 0 and 1 here, that is also your output will be 0. If you give 0 and 1 here, yeah, that is also 0. Still you can't find. I'm giving 1 and 0. You will see. So definitely your output will be 1 here. Here 1 and 0. Definitely your output will be 1. 1 and 0. Here also 1. Right? Then I am using 1, 1. Here also 1, 1, 1. So all are giving the same output. So this is fourth answer. So one student is asking, sir, is it better to draw the truth table? To draw the truth table, you have to find out the expressions and draw them. I think it is taking time more than this method. That is also correct. That's why I told when I'm starting, there are several methods, but I feel it will be taking more time than this method, right? It doesn't matter, you can use any method, right? Okay, we'll go to the another question. Okay, this is a essay type question. Okay, try it out. Okay, we'll see. So flashing with motion light sensor is located outside in front of door of a building. The light turns on automatically when it is dark and when someone approach the door from outside. So whether both conditions are satisfied, definitely that both conditions are satisfied, there should be an AND gate. We can like guess, but we'll go through. The motion sensor turns from off to on when someone comes to the, so that means motion sensor should be 1 when someone comes near the door. The light sensor is on when there's a light and off when there's a dark. So there should be 0 should enter to this circuit. So definitely to make it, because when it is dark means 0 means light sensor whatever taking the value should be converted to the 0. That means P should be not gate. P should be not gate. And Q should be both the condition is true, only it is working, that should be AND gate. Okay, right. Then next part, read it and what are the suitable logic gates? Yeah, that's what we did. Then the above second modified by adding an O gate, and switch on 1 of 0 as shown below. Identify which of two in the following statements are correct regarding the modified circuit. Now you can understand when the switch is on, whatever the condition from this part, so other part, your output will be 1, right? Your output will be 1. That is the main thing you should know. Okay, we'll see the statement. When switch is on, the flashlight will always be on. Yeah, that is correct. Then when switch is off, this circuit behave as the circuit in figure 1. Yeah, that is also correct. The behavior of two circuits are identical. No, because of the switch, it is different. So first two are correct. Yes, so what are the gates for P and Q? That's what I told. I don't know whether you were there or not. P is here same thing. Not gate. Q is AND gate, right? Same thing, right? So asking yes, light sensor. Light sensor is working 1, and the dark it is 0. But in this case, this alarm will be triggered when it is dark. So that's why we used not gate here to whatever the value to convert it to 0 when it is dark. To give the signal it is dark, you have to insert 0 to the AND gate. That's why we are using not gate. Okay, right, we'll go to the other parts. I am answering most of your questions here, but with the time, sometimes I may miss them. So you can, I will give my number. If you have any problem, you can put me a message. Okay, this is also kind of a structure part. Okay, try to do that. Okay, there are P and Q. So the ceiling fan is working when the temperature is high, while the power switch is on. So power switch on means 1, temperature high means 0. So you have to insert 0 here. But from here, if you are getting 1, to convert it to 0, complement, Q should be not get. Q should be not get, and both the conditions should be satisfied. So P is and gate. P is and gate. Okay. Part B also, write out. I think it is easy, right? So to work, power should be on, door should be closed, otherwise it won't work. The water level should be full. All are 1 because it's AND gate. All are AND gate. So all are AND gate means all should be 1 to get the output. 1. Working means 1. Right? So these everything should be 0 except last one. Last one should be 1. Others are 0. Okay. Most of you have put the correct answers. Okay, I'm going to another question. Some MCQ questions. Okay, try to do them. Okay, we'll see that one. Here, asking truth table, they have given truth table. See, if you get 0, 0, 0, 0, here you get 1 and 0, but it's a no gate. If you get 1, 0, you get 0, right? So that means we can cut this. This answer we can cut without any problem. Then I am giving 0, 1. 0, 1. So it become 1, 0 when it is it is 1, 1, 1, 1, again you are getting 0. 1, 1 you are getting 0. Again you can cut these two answers without any problem. I don't want to check further. I have found the answer. Second one. Right, second one. Okay, we'll go to the eighth one. Eighth question. Which of the following logic circuit has a truth table equivalent to the truth table of the logic circuit shown in the right hand side? So right hand side means this one. So here you get actually A dash plus B dash. A dash plus B dash. Right? Then try to find out what is equivalent one. If I write here AB, then A dash, then B dash, then A dash plus B dash. This is my truth table, right? So if I put value 0, 0, A dash means 1, B dash means 1, A dash, B dash means you will be getting 1. So 0, 1, if you give 0, 1, so A dash means 1, B dash means 0, there also you are getting 1. Then if you give 1, 0, your output will be here you get 0, here you get 1, your output will be 1. If you get 1, 1, your A dash means 0, B dash also 0, your output will be 0. So what is this gate? If you get 1, 1, you get 0, otherwise 1s. That is actually NAND gate. But here, yeah, it has given directly NAND gate. First one is the answer. Right? So you can find it out easily. Okay, we'll go to the rest of them. One of you asking, sir, can we use the De Morgan's law? Yeah, that's what I want to tell. There are so many Boolean laws are there, but they are not in your syllabus. In your syllabus, I'm doing A level students also. I'm teaching, so there are so many Boolean expressions, laws are there. We can apply them minadit, right? We can apply them in the, but here in your syllabus you don't have. Earlier syllabus, that is from before 2016, your syllabus was changed from 2016. Before 2016 you had this Boolean De Morgan's laws, right? Here, but in your syllabus you don't have, so don't try to use them, so you don't get, sometimes you don't get marks, right? So here to find out the question, it doesn't matter if you know that, it doesn't matter you using them, but in your book or in your syllabus you don't have them, so that's why I'm not going to teach them. Then if I teach them, you will be confusing, most of you will be confusing, right? So there's no, don't worry about the Boolean laws. Okay, we'll go to next question. Okay, this question, find out the answer. I'm waiting for your result. I think this is from 2019. Okay, we'll see the answers. Now here, yeah, see if 0 and 1 respectively are given as input for x in the following logic circuit, what would be the to respect output? Now I am giving 0 here. When I am giving 0, what will happen? So it is coming, it become 1. Here it is 0, right? So if it is a AND gate, sorry, if it is an AND gate, whatever it is in the B, your output will be 0, because if you have 1 0, definitely your output will be 0, right? Here it depends. If you have 0, your output will be 0. If it is 1, A is 1, your output will be 1. That means this output depending on this one. So if you are getting 0, definitely, because this time this way you are getting 0. So no any doubts, right? But other way around, that means from the A, if you get 0, your output will be 0. If you get 1, your output will be 1. That means this output depends on A. This output depends on A. So if you give 0, your output will be A, right? Your output will be A. Then if you give 1, we'll see. If you give 1, I'm giving 1 here. So 1 is coming here. But here you are getting, because of NOT gate, you are getting 0. So 0 means definitely whatever it is, whatever in the A, doesn't matter, your output will be 0 from this gate. But because of 1, if you have 1 here, your output will be 1. And if you have 0, your output will be 0. So that means it depends B. Y is depending on the B. If you enter, or if you insert 1. So that is B. That means A and B, second answer should come. Second answer should come. Okay, we'll go to the another question. Yes. Okay. I think that is 2019. Do it quickly. First question, consider following A. One of the student asked this kind of thing. I don't know whether he's here or not, right? So A is given, draw the truth table. Truth table you have to draw. So you are giving A and A also getting. Both the A is coming, right? Because it's a NOR gate. So your output will be, you are getting A A plus A dash, right? So actually you can take, it is working like a NOT gate. So I am giving 0 and 1. Now if it is how it is working, that's why I wrote A dot A. It becomes A dot A. So you can write because two inputs are there, because NOR gate you have to have two inputs at least, but here A you can have either 0 or 1, but your P will be, it's working like a NOT gate. If you get 0 0, you will be getting 1. If you give 1 1 1, it become 1 1 because it is two separated to two gates. 1 1 you get 0. So this is your truth table. This is your truth table. Okay, write down the expression for the last one also. Minadit has put the output 0, 1 0. Don't write like this because you have one input here. That is how it is working. That is how it is working. But when they are asking the truth table, you have only one input, right? So all the time, either 1 or 0, two patterns. That is, it's work like a NOT gate. It's work like the NOT gate. Don't put four patterns. So here we'll see the expression. Here you get x dot y dash, x dot y dash. Here you get x dash dot y, x dash dot y. So both we have to combine here. That means you can write the answers x dash, x dot y dash plus x dash dot y. So this is your answer. Vidushi, Vismita, yeah, Danuja, all have put the correct answers, right? Okay, I have taken only 2017, 89, 19 question, right? So I will share the yes, this is the link. You have to log in to do the quiz. I sent through the chat even. Yeah, I'm sending it. Okay, now you can yes, right? So you can log into that and try to answer. Okay, right? So you can log into that and try to answer. I will be closing the link by 9:30. By 9:30, I am going to close that, and I am finding the rank of you all, right? So this lesson bit, even this is bit confused. I try my best to make you understand, all of you, right? What I want to tell you now, when we have, I told you that day also we have parallelly we are having Sinhala medium seminar also for you all. Uh, but most of English medium students were asking for English medium seminar. So our, especially I want to mention here, ICT director of our zone, Gampaha zonal ICT directress, Mrs. Srimali, wanted to, actually she was pushing us to do this kind of a seminar for you all. uh, she's the actually pilot or the leader of our all these programs. So that's why we have arranged this kind of a program for you all. I think some of you, those who couldn't participate for this seminar, you can go to that my channel, ICT Anil sir, right? Go to that channel and I am going to upload this uh, video within another few minutes. And you can, this is my phone number, I think I have given that day also. If you have any queries related to this logic gates part, you can ask. Some of you have put some messages, I have answers with my time. If I am busy, sometimes I may not able to answer, but later or even I will be answering them, right? Okay, so I think you can understand those things. This is a bit even bit hard, but you can get marks from this part, right? So okay, so thank you for everyone for participating. Okay, we'll finish for the day. Have a nice day.